Software Engineering Radio, episode 121, Object-Relational Mappers.
This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio brings you relevant and detailed discussions and interviews on software engineering topics every 10 days. Thanks to our audience and the partners listed on our website for support.
Hi everybody, and welcome to another episode of Software Engineering Radio. My name is Arno, and today I am interviewing Michael Plöd about Object-Relational Mappers, or ORMappers, the technology to get object-oriented languages in sync with the database. Michael, would you like to start by introducing yourself, saying a few words about yourself?
Okay, hi everybody. Thank you very much for listening to this episode of SE Radio. My name is Michael Plöd. I work for a company called Senacor Technologies in Nuremberg, Germany. And my role is, I'd say, chief developer or architect, or however you may call that role. Usually working on longer running projects. And I started working with ORMappers a couple of years ago. Mainly, I've dealt with the Java-based mappers called, like for instance, Hibernate or JDO, or nowadays JPA, the specification. And I'm happy to hear some questions. I hope I can answer them.
Okay, well, let's get started by talking about what is an ORMapper. What is it about?
Okay, basically, an ORMapper is something that addresses the object-relational mismatch. There is a natural mismatch between object-oriented software and databases. Mainly, if you look at, for instance, how you group your business logic or your domain objects and how you define a relational schema, you will clearly see from the beginning that, for instance, you work with classes and attributes, and you have some sort of types that are defined either by the programming language, or you define your own types in the programming language you're working with. On the other hand, you work with tables and columns, and you group these things in schemas. And in a relational database, you also have a type system, but this type system is very static in most databases. Of course, a lot of databases have some sort of user-defined types, but usually this support is not as sophisticated as the support in a lot of the databases. Another thing is the navigation, how you navigate between graphs of objects. In object-oriented software, or in software general, you know how you navigate from entity A to entity B. On the other hand, the relational database, the navigation doesn't have a direction. So you could navigate from the customers table to the billing details table without any problems, but you could also navigate through the foreign key from the billing details to the customers table. So you see there is no path of navigation.
Okay, but to access this kind of data, you have the SQL programming language or
Yes.
things like that. Why do you need an ORMapper? What is the advantage of using an ORMapper above using SQL and the database access technology of your language of choice to directly access the database?
Basically, you use an ORMapper to encapsulate the database to a certain degree. A lot of the vendors, they say, okay, you can easily switch the database by using an ORMapper. Yes, this is true, but I would say that in most of the big projects or big companies out there, switching a database is a very, very rare kind of thing. I think the major use case or the major benefit of an ORMapper is to have developers work with objects and not have them code a lot of business logic in statements, or like the statement processing that you mostly do with SQL. And in addition to that, a lot of the libraries that implement the communication with SQL are very low level. For instance, if you look at JDBC, this is a very low level library where you work in statements, you work with result sets, and you iterate over them. You have to do a lot of resource management. And an ORMapper totally encapsulates you from this point of view. So you have some kind of metadata, be it, for instance, XML annotations or some other kind of, or even design code conventions that describe how you map your classes to tables and how you map relationships or inheritance or anything else.
So is an ORMapper about making a relational database look like an object-oriented database?
No, I don't think that this is the main intention. Of course, from a developer's point of view, you still work with objects and you have some kind of access to the database. Like, for instance, if you look at JPA or Hibernate, you have something like the session or the entity manager, which is a persistence context, which could be seen as an OO database, but they are no OO database in the end. Or if you look at active record, where you call some persistent related methods on your object, like save or a list or retrieve or something like this. I would say that this is the wrong kind of thing to look at an ORMapper as treating it as an OO database. They have some features of OO databases. For instance, a lot of the queries from certain ORMapper implementations, like with criterias and so on, you also find this stuff in OO databases. But in the end, the data gets persisted in a relational storage.
So although you have an object-oriented programming paradigm, you still should be aware that it is stored in a relational database because of performance aspects and other non-functional aspects of your storage.
Absolutely. I would say it's an illusion to think that once you start using an ORMapper, you don't have to bother about relational concepts in SQL anymore. I know that there is a lot of advertising regarding this issue, but I think this is actually very dangerous, because you as a developer that works with an ORMapper have to be able to see what SQL is being sent to the database, and if this is good SQL or bad SQL, or if this is too much SQL that gets sent to the database. So in my eyes, if you start working with an ORMapper, you still need to have some solid background regarding SQL and the relational database that you are using. Especially when you do performance tuning, this is very important.
Yeah, I understand that, but a moment ago you said an ORMapper encapsulates the database, and now you say you still need to be aware of the SQL statements that are parsed between the ORMapper and the database. Doesn't this reduce the improvement you have? Doesn't this sort of undermine the benefits of an ORMapper?
Yes and no. There is some truth to this, because in the end, an ORMapper is, in my eyes, never 100% solution for every use case out there, especially when you want to do performance improvements on an integrated legacy database. I would say an ORMapper is always a 95% solution or a 90% solution regarding the problems that you face when you integrate a relational database to an object model. I would say in most of the cases it is an encapsulation, so you don't write any statements anymore. You don't deal with low-level resource management when you work with an ORMapper. And in most of the use cases, you just describe how an object gets mapped to a database and you work with it and you don't have any problems. Of course, there's corner cases where you might think that falling back to SQL is an option, and I absolutely don't discourage that option, but just choose it carefully. Only in absolute exceptions, falling back to SQL might be a solution that is worth thinking about.
Okay, so basically it's useful and takes basically a lot of effort and helps a lot by encapsulating for most of the cases, but in exceptional cases you still need to be aware of things that go on below that.
Absolutely.
So this is sort of the beyond the PowerPoint and advertisement and buzzword level, yes, it is useful, but you need to be aware of the details in some cases anyway.
Of course, I would say usually when you roll out an ORMapper in a team, you need to have some people in the team that have a detailed knowledge of the ORMapper and the SQL, and they spread the knowledge so that the developer that is writing the standard business logic in the team doesn't need to care about all the bits and the pieces. I don't say that every developer should be an absolute ORMapper or SQL crack. I just say that you need to make sure that the knowledge is available to you, and it is also absolutely fine for instance, a Ruby or Java developer to walk over to the DBA and tell him, "Oh, listen, is that okay what I'm doing here?" I think there is often a lot of boundaries between these teams, and this is wrong. There shouldn't be boundaries between the teams.
That's certainly true. But let's get down more into the details, into the concepts behind the facade of the ORMapper. What does an ORMapper actually do?
Okay. What an ORMapper does is it takes some sort of configuration in the beginning. For instance, you define how you get to the relational database if you are working in a managed or non-managed environment for transaction synchronizations and for looking up data sources or connections to the database. There's some differences between the environments that you're running in now, but I don't want to get into detail here because this is mostly infrastructure related. More important is that an ORMapper reads some kind of metadata information where you specify how you map objects to tables and how you define associations between the objects and how these associations are reflected in the database. Again, there are many options. For instance, you could have an one-to-many relation over a join table, for instance, because this relation is optional and the database designer didn't want to have nullable columns in the database. So you need to specify all of this, and the ORMapper takes this information and is able to generate SQL that fits the operations that you're doing on the ORMapper to the database that you are running under. So another key concept of an ORMapper is some kind of dialect. So the ORMapper needs to be able to talk to as many databases as possible, because you want to abstract from a specific database to many databases. So this is also the reason why ORMappers are very popular for software that is being sold that needs to run in as many environments as possible.
Different database vendors solve the same problem in different ways, interpret the SQL standard in different ways,
yes.
And the ORMapper knows how to speak the dialects of all the products without forcing the developer to know all the details of all the products.
Exactly. Absolutely, and the ORMapper also has more knowledge that regarding SQL. I would say a good ORMapper has that, because some SQL on some database is performing better than some other SQL against the same database. So you would also have improved SQL in the database dialect of the ORMapper. I would say we get back to that point later when we, I think, talk about performance impacts of ORMappers.
Yeah, let's do that.
Another key concept of an ORMapper is the type system. There are types in the world of the programming language that you're working with, and also the database has its own types. So in some cases you need to transform to these types, or the ORMapper needs to have a facility how you map your own defined types. For instance, a currency amount, where you have an amount, let's say 100, and you have the currency US dollar. How do you store this object called currency amount to the database? So this is also a very important part of the ORMapper.
So the ORMapper sort of adds abstraction. You can work at a higher business sort of abstraction when you persist your data without being forced to do the transformation explicitly all over the place to raw SQL. Is that what you're talking about?
Yes, exactly. It's you abstract from a type system. Like you have an you as the Java developer don't want to work, or you as the developer of software, be it Java or Ruby or whatever, want to work with your own types and don't want to work with any ORMapper or SQL specific types. And so the ORMapper needs to abstract from the underlying database types. That's what I meant.
So we're saying an ORMapper transforms the application type system to the database type system, and you declare the mapping between the two in a single place, so you can use your application and business logic type system all over the place and directly map it into the database.
Exactly. And in the ideal case, you have some defaults. For instance, you map a string to a text or a var character or something like this in a database, but you could also specify, okay, I want to map this to that type.
Okay, what about, this was about primitive types. What about relations between data, references and foreign keys and stuff?
Yes, this needs to be specified in the metadata for the ORMapper. A classical example regarding the differences between a relational database and object-oriented software are M2M relationships. In the relational world, you would work with 3 tables for that. You always have a mapping or a join table in the middle that provides you with the ability to define the end-to-end relationship. Whereas in the object-oriented software, you would just have two classes with, for instance, 2 collections on each of the sides. So you need to specify the relationships. If you want the relationship to be unidirectional or bidirectional, well, that's, I would say, in your code. And then you also need to specify how this relation is designed in the database. So for instance, if you have a one-to-many relationship and then you specify, do I have a join table, for instance, if it's an optional relationship, or what is the foreign key column, and so on. So this is a part of the metadata and also of your code. A very important thing here is that most ORMappers don't manage bidirectional relationships for you. So this needs to be done in your code as well.
What about object identity? In the relational world, you have everything value-based, and if 2 rows have the same values in every column, they're indistinguishable, whereas in programming languages, in O languages, you can have different objects that have, well, the same values in all their fields, but still are 2 distinct objects. How do ORMappers bridge that gap?
Yeah, if you define, I would start off with entities. A lot of the ORMappers differentiate between components or value objects, for instance, and entities. An entity always has a constant ID in the object-oriented world. This is a concept, for instance, that was very nicely explained by Eric Evans in the Domain-Driven Design book. And I like to use these 2 kind of words for ORMappers as well. Let's start off with entities. An entity has a constant ID. In the relational world, this refers to the primary key of a table or of a column. So if the primary key is 1 of row of some set, result set 1, and another result set has the same primary key, we're talking about the same row. This is the reason why you would always specify a primary key attribute or an ID attribute in an ORMapper. So there is a difference. Usually you would work with 1 column as the primary key and with 1 attribute in your entity class. But this can also be extended to compose primary keys, where you have 2 or 3 columns making up a primary key, and you would have 2 or 3 columns, 2 or 3 attributes making up the primary key or the ID of the object. But this is how the ORMapper reflects the primary key. However, there is also the concept of object identity. For instance, in Java, you would implement equals and hash code for having a business key. And what I've seen is that in a lot of projects, the primary key would be part of these methods, which is kind of dangerous because the primary key might get created at a later stage. If you're working with a new object, let's say you create a new customer and the primary key would be created at the end of the transaction or as soon as you save the object to the database. But so you could have two customer objects, one with a set primary key by some default mapping on the service or web service level, and one that you just instantiated. From a business point of view, you're talking about the same object, but if you have the primary key in the equals and hashcode method, you would still get a difference between the objects.
But how do the ORMappers deal with the situation that you can have several distinct objects in the OO language that actually refer to the same row in the database? This concept of object identity, which is not present in the database.
Yes, a very important concept for some ORMappers out there is the concept of object identity. This concept is found in any ORMapper that is working with some kind of persistence context. This is also called the unit of work, or and contains a first level caching system in most of the ORMappers. That means if I start a unit of work, for instance, I have a simple request and response cycle on a web app. I open the persistence context and I load a customer with the ID 123, and this customer is then being stored in the persistence context. If I go in another business method to the persistence concept and load the customer with the same ID again, I would get the same object. So also object A equals object B would then return true, and so should of course equals and hashcode. If you close the persistence context or remove the object from the persistence context, you would no longer have the guarantee of object identity. So in this case, you can no longer trust that you're still working with the same object in this case.
Okay, basically you have this unit of work concept that corresponds to the database transaction, and inside this unit of work you have only one object corresponding with the same row, and then when several transactions are running in parallel in memory and they commit, they'll have all kinds of conflicts. But this is the concept of ORMappers behind behind isolating several instances that refer to the same row.
Exactly, yes.
This just sounds like there are two things that ORMappers do. One thing is reading and modifying and primarily writing objects.
Yes.
And the other thing is querying.
Yes.
Reading data. Let's get to the reading of data. What support do ORMappers have there? I mean, that's the big strength of relational databases, that you have all the freedom in the world to write arbitrary queries using SQL select. What do ORMappers do about that?
Okay. There are many ways to retrieve data from a database through an ORMapper. Usually they come with easy access methods like query by a primary key, retrieve a proxy with an ID that gets lazily initialized. You could load all the data from the database, for instance, what you would find with find all methods, for instance, in Active Record. And then you also have, in most ORMappers, a query language. And the big difference between the query language of the ORMapper and SQL is that in the case of an ORMapper, you are querying against objects and not against tables and columns. So this, I would say, if you have a sound SQL background and you want to get into the query language of an ORMapper, the first thing you have to be aware of is this difference, because you don't deal with tables. And another kind of query language is, I would say, more object-oriented query languages, for instance with criteria, where you abstract from a text-based query language to an object-based query language.
So you have an API for
Yes.
plugging your queries together.
Yes. You use an API and you define restrictions, projections, you can define ordering, and you can also specify how you want to fetch data from the database. Because sometimes you know that when you load, for instance, a customer from a database, you always want to have his addresses, all the addresses that the customer registered. So you could do that in one fetch. So you can define fetching strategies either in the object-oriented querying with the API, the criteria API, or you could also do that in the text-based query language. Another aspect is querying by example. This is often part of the criteria APIs of the ORMappers, where you provide the query instance with an example object. For instance, any customer with the first name Arno, and you would specify some hints to the ORMapper, for instance a match mode, so that you say, okay, I want an exact match, I want to ignore the case, and so on. So this is another querying facility that especially comes in handy for search screens. And most of the ORMappers nowadays also have support for falling back to native SQL. This is of course not the first choice you would do when you work with an ORMapper, but there are use cases when you want to use some database specific features, or if you want to do some very low level database tuning, you could fall back to the native SQL. And the ORMapper then provides you with a mapping from the result set, or from the low level SQL result that you get from the SQL query to the object model that you are working with.
There used to be a hype of ORMappers. The hype is sort of over, but still a lot of products call themselves ORMappers. There's all kinds of things. There's things like Hibernate and Hibernate. There's Ruby on Rails and the whole group of products that sort of follow that lead. There's Link. There's all kinds of things. Could you give us an overview of what kind of ORMappers there are out there and what the differences are? Maybe categorize them a little.
Okay. I would start off with the first categorization. If an ORMapper has this concept of a persistence context or the unit of work or not. In this range, there is, for instance, Hibernate. JDO was also in this category, or in the Java world, the JPA specification also specifies a unit of work in this case. And Hibernate is also part of this category. The next category would be ORMappers that take metadata information, but still work very, I would say, statement oriented. For instance, if you look at the support in Ruby on Rails, you don't have the persistence context in active record, for instance. So you would create an object, save it to the database, and if you then change the object that you just saved to the database, you need to call an update method. So you don't get this transparent synchronization with the database in this case. So here you always have to say, okay, sync my changes with this object to the database. Link, on the other hand, is mainly a query language. I mean, Link is not just limited to a relational database. So you would have link to objects where you query objects in .NET. You would have link to XML where you query on XML structures, or link to SQL where you work with queries on a database. But also Link has some kind of mapping between a very tool-driven mapping for mapping the object to the tables in the database. But Link's main focus is actually queries, and they also have means for storing and updating data in the database, but I would say the main focus of LINQ is querying. There's also a lot of discussion if, for instance, some low-level statement frameworks can be seen as ORMappers. For instance, in the Java world, you would have IBatis, SQL maps. So there you also have some kind of specification how you get from objects to the database, but this is very statement-oriented. So I would see these tools more or less in the framework section, and I wouldn't see them as ORMappers, where they have some aspects of ORMappers, but they are still very, very absolutely statement specific. So you define your own queries. So these tools, they don't make up queries for your objects. There you have to specify all the create, read, update, delete, the CRUD operations, and so on. Yeah, so that's the main categories I see in terms of ORMappers.
Mm-hmm. Okay, you sort of talked about the different programming models of different ORMappers. Let's say I want to start a new application, and I'm considering using an ORMapper. How do I go about it, and what impact does the ORMapper have on the design, on the architecture of the new application I'm writing?
Okay, I would first evaluate if I really need an ORMapper for my application. If this is a very small web app, and you, for instance, just have 2 or 3 classes and you want to put them in a database, maybe an ORMapper would be just another library, more configuration, more metadata, and you would have been very much faster with plain SQL in this case. But most of the projects that are out there are more complex. So in this case, I first need to evaluate which kind of category of ORMapper I want to use. Do I want to have the full-blown ORMapper, which is very powerful, and in most cases, for the easy use cases, also very easy to use. But they also add a complexity, because the developers in the team, they must be aware that, for instance, changes they make to objects get synced to the database transparently for them. And you can also run into several areas of conflict. So is there knowledge about this kind of category for the ORMapper in the team? If this is the case, you can easily go ahead and integrate one of these ORMappers to your team. If this is not the case, maybe you add a specialist for the ORMapper.
Okay, this is sort of the generic advice for introducing new technology of any kind. But let's say I have a business application which is sufficiently large, and my preliminary research tells me that Hibernate and Hibernate are one of those full-blown ORMappers is a good choice. What impact does that have on the design, on the architecture of my application? How do I go about it?
Okay, the impact is, first of all, that you have to add metadata to the application. So you usually then have your classes and objects, the relationships between them, and you have the database on the other hand, and you have to put them together for the ORMapper. So you need to specify metadata for that. So either through an external DSL or an integrated configuration. This is the first thing. Another thing that you need to integrate into your application is the management of the persistence context, so the unit of work. Where do my units of work start? How do I end them? How do
the planning the transaction borders?
Exactly. How do I plan and integrate with the transaction management? Am I working in a managed or a non-managed environment? Or do I need to have support for long-running conversations, where I keep the persistence context open, but I commit every time and flush manually at the end? And you also have to think what you do with the mapped objects. Am I passing them right to the client application if I have one, be it a web application or an RCP application? Or am I working with another layer for the service level, for instance, the DTO layer? So this also needs to be considered.
Mm-hmm. Okay, let's say I'm starting the development of a new application from scratch, which is sort of the best case, the dream of every developer. Do I start by creating my object model and then just map it to the database in a straightforward way? Or do I first design my database and then sort of mirror the database in the objects? How do I go about that? Objects first or database first?
There is usually when you as a object-oriented developer work with your application, you of course would say object first, and I would also think that the objects that you're working with in your application should be as expressible as possible. But I would always maybe once a week talk to a database specialist and say, hey, I have this object structure and I want to map it like this to the database. Is that fine, or do you see any performance impacts on this? Because if you have a very nice object model, but you screw it up on the database side, the business value of the application dramatically goes down. I would always start with the objects, but keep the persistence aspect in mind and think critically, and maybe have somebody review how I think about the database as well.
So basically you're saying objects are the primary abstraction, but it's important to keep the database model in mind and sort of do round trip and have them both evolve in parallel.
Yes, I would actually say this is best. I would always sit down with a domain expert who has a thorough domain knowledge. I would make up my object model and then talk to a data designer how he thinks or she thinks about this object model and how we could reflect that in the database, what they think. And I think these collaborations between these three views, the business side, the developers, the OO developer side, and the database side, will make up the most efficient application.
Okay. Another thing is encapsulation of the ORMapper product. Should I still have a data access object layer to encapsulate the ORMapper, or should I sort of use it all over the place?
I know there's some discussion about this point, especially in the context of the Java Persistence API specification, but I would still say absolutely yes for the data access object pattern. There are several reasons for this. The first reason is very obvious. I don't want to deal with persistence-specific technologies in my business logic. This is not part of the business logic, and the business logic shouldn't care about where and how the data gets stored. This should be abstracted. The next part is you could switch the persistence technologies, and I would say this is the weakest argument, because usually you evaluate a persistence technology, you test it, you stress test it, and then you roll it out into a bigger development environment. And this is a very rare case that you would switch a persistence provider. It happens. I would say it happens more often than you switch a relational database. But the main advantage by having a DAO layer is that you can define a standard behavior how you, for instance, use the ORMapper's API. For instance, do I always, when I look up stuff by the ID, do I always hit the database up front, or do I generally work with proxies? Do I, for instance, in the case of Hibernate, use the method save or update, or do I want to work with merge? How do I flush the changes of the persistence context to the database? And
so you're saying what you're saying is the details of interacting with the ORMapper API should be abstracted away to be done in a uniform way and not to clutter the business logic.
That's one argument, and the other argument is that I can define standardized CRUD behavior in an abstract superclass of the DAO that is technology specific, and the developers, in the ideal case, only need to implement queries.
Okay. Well, what about lazy loading?
Yes.
Well, lazy loading is a feature that many ORMappers have, and lazy loading means that when you navigate along object references, and while you're navigating along the object references, objects are pulled in the background. SQL queries are executed in the background. Doesn't this sort of behavior sort of tie the business logic or create a coupling of the business logic to the persistence sort of through the backdoor?
Yes, there is some kind of backdoor, and I would say the lazy loading pattern is a very good pattern, because if we wouldn't work with lazy loading in the context of ORMappers, there would be a danger that we would load up half of the database on every request, even if we don't need the data. So in the end, the lazy load pattern says, okay, I only load stuff when I really need it. For instance, if I have a collection and I need to access some of the elements of the collection content gets lazily loaded. So in this case, of course, some business logic triggers some SQL statements, but the business logic never says, okay, now please persistence provider initialize this for me. It's happening transparently in the business logic. So I don't buy into the argument that there is a tight coupling between persistence and business logic through the lazy load pattern being used.
But talking about coupling and its impact, what about the overhead of having the ORMapper stand in between your application and the database? Doesn't that negatively affect performance?
Yes and no. On the one side, yes, you have one additional layer, you have an additional library that is running in the application, and this costs some performance. I would say it is, with the majority of today's ORMappers, no longer a showstopper for most applications. Maybe some extremely high performance real-time applications, they will consider this, but a lot of the enterprise applications that I've been working on, they didn't even feel the overhead of the ORMapper, because on the other side, the ORMapper also, or let's say a good ORMapper, sends good SQL to the database regarding on the dialect of the database that you're working on. So in the dialect of a specific database, there's also knowledge how or which SQL is efficient on that specific database and which SQL is not efficient. So the average developer that has usually some kind of knowledge of SQL doesn't need to bother about the very low-level performance relevant details of the database. This gets encapsulated, and I've talked to quite some DBAs that say that the SQL from many ORMappers is actually pretty good for them. There's not everything is good about this, but most of the times they say in the end, when they test a use case, the performance is actually better.
You mean the performance of accessing the database through an ORMapper is better than the performance would be with typical hand-coded SQL statements?
Yes, especially typical by an average developer. If you have developers that are database experts, and they will always be able to outperform the ORMapper, because they know every bit and pieces, but you don't get the abstraction from the database anymore, and the applications wouldn't be portable then.
It sounds a little like the discussion of the performance impact of a virtual machine versus hand-coded assembly language.
Yeah, something like this. You will always find people that say ORMappers are so slow, but I think the reality is that not every developer can be a database expert in terms of writing the top performing SQL for database X. So I think that I really think that ORMappers at least don't drive down the performance if you're using them right.
Mm-hmm. Well, what about caching? You said that the unit of work usually does some caching for the abstraction, for the isolation between transactions, which is, well, it's sort of caching, but it's caching for the scope of a single transaction. What about longer caching?
Yes.
Does it pay to do that? What level of support do ORMappers have there? Is it a good idea to use that? And if so, when should you use it and when should you avoid it?
Okay. I'm having a very conservative stance on caching. Before I start introducing a second level caching mechanism to an ORMapper or to the infrastructure of the ORMapper, my recommendation is to first tune the plain data access. So that means only load data you really need. Think about aggregation, projection in queries, and tune the queries up front. After this has been done, I would assess which entities or which use cases would benefit from caching, because not every kind of class would benefit from caching. For instance, a very bad candidate for a cache would be financial data, because if you run into a problem with a cache, your organization could lose a lot of money. On the other hand, reference data, as for instance country lists or stuff that
you mean master data that rarely changes and is referenced by many other tables.
Yes, I would classify this data as data that rarely changes, that is being needed by many users and many different users, and also data that gets asked for very often and data that is not very critical. I wouldn't want to cache mission critical data,
because caching adds the risk of the cache being outdated.
Yes. There you have to differentiate between several isolation levels for caches. In most of the caches, or you can define a certain isolation level. This can be up to a fully transactional cluster replicated cache, or to a simple cache that, for instance, still maintains read committed isolation on the transaction, and that's working a lot with idle times, and that is not shared across a cluster. That is running on one instance and not on many instances, and there is no synchronization between the nodes. So from this argumentation, you also see that you add some kind of complexity to the infrastructure if you introduce a cache. This may not be very complicated for smaller caches, but if you want to integrate a cache that is synchronized across a cluster and fully transactional and replicated and so on, you always add a lot of complexity to the infrastructure. And this shouldn't be done, in my opinion, by the specialist for the ORMapper. In this case, I would ask a specialist for the cache, because there is a lot of stuff to configure there too.
Okay. So caching, yes, as sort of the last line of defense, but not something to use lightheartedly.
No, I would say caching, yes, but only introduce caching after you have tuned everything else.
Okay.
And also query caches are widely used, but in most of the use cases, they are not very efficient in my eyes. So you could cache entities and relationships and also queries, for instance, but a query cache has a very rare justification, I would say.
Okay.
But still, you can consider this if you know this query gets executed with the same parameters up and up again.
Okay. What about data migration and ORMappers? What about applications accessing the database by different means than through the ORMapper? Is that a problem?
Absolutely, especially if you're working in an environment with caching, because your application can never know when another application changed the data in the background. This is mostly the use case when you when you start off with an existing database that has some stored procedures or other legacy applications working on the database, and then you set up a new application with a new architecture where everything is nice and great technologies and so on. So then you never have an exclusive access to the database, and you always need to be aware that stuff can change in the background. And yes, especially this is dangerous in a caching environment in my eyes. So in this case, I would be absolutely conservative with caching and wouldn't really recommend caching for most of the entities.
You mentioned stored procedures. Stored procedures are seen by many as the fastest way to really high-performance database applications. But stored procedures don't work very well with ORMappers, or do they?
Actually, no. You have support for stored procedures in ORMappers, but usually the support is very limited. And I've actually personally never integrated a stored procedure with an ORMapper. Of course, yes, stored procedures are absolutely high performing, super fast, and so on. But in the case of stored procedures, you always have to be aware that you bind like the data very strongly with business logic. Of course, they are encapsulated in own packages and so on. But also the maintainability of a stored procedure is in my eyes harder than the maintainability of well-written OO code. Of course, you could write unmaintainable OO code, but usually, especially when you want to find out, for instance, where do I find that? Where is that database link being used, or where do I use this and that? This gets very uncomfortable with stored procedures. So stored procedures, in my eyes, are very great for batching jobs. That's the domain where most of the ORMappers really fail, because an ORMapper is no batching tool for high performance. So this is in my eyes, the main domain for the stored procedures.
Well, from my perspective, I think we basically covered the ground. Are there any final words you would like to say? Anything you would like to add?
Yes. Thank you very much for listening to the podcast. I'd be happy to take some feedback in the comments, and I'd be happy to reply to them. Regarding using ORMappers, I would definitely encourage looking at ORMappers, but don't use them because they are fancy or anything like that. Only add them when there is a business value, and especially with caching, be a little conservative. I'm not discouraging caching, but just a conservative stance to it. And don't believe any ads that say you don't need to learn SQL anymore when you use an ORMapper. This is a lie. Thank you very much.
Okay, Michael, thank you very much, and thanks everybody to listening. Bye.
Bye.
Thanks for downloading and listening to Software Engineering Radio. Software Engineering Radio is an educational program brought to you by Hillside Europe. If you want more information about the podcast and all the other episodes, visit our website at se-radio.net. If you want to support us, you can donate to the SE Radio team via the website, or you can advertise for SE Radio, for example by clicking on the Dig, Reddit, Delicious and Slashdot buttons. To contact the team, please send email to team@se-radio.net, or if it is specific to an episode, please use the comments facility on the website so other people can react to your comments. This episode of SE Radio, as well as all other episodes, are licensed under a Creative Commons 2.5 license. Please see the website for details. Thanks to Charlie Crow and the Podsafe Music Network for the music used in this show. The song is called Vegas Hard Rock Shuffle.